Welcome back. We're going to be going through quadratic equations. It's a little bit different than quadratic expressions because this time we're going to have an equal sign in it, and we're going to be solving for values of x. And by the end of this, the big learning goals of this unit are to interpret and solve questions related to quadratic relations, similar to what you've been doing before, except we've got an extra step added in here. As a quick review, I encourage you to pause the video at this point and try and factor these expressions. Now that you've had a chance, this is going to be a quick review. Factor out the 3. This turns into 3x squared plus 3x. 84 divided by 3 is going to be 28. We factor this expression here. Two numbers which multiply to minus 28 and add to 3 are going to be 3 and minus 3 and positive 7. No, sorry, 4 and 7. It's a positive number in the middle, so the bigger number is the 7, and it's positive x minus 4. We're going to factor this expression here. There are no common factors, so we take the a value times the c value. That means it's going to be minus 80. Two numbers which multiply to give us minus 80 and add to give us minus 11, I believe, are 5 and minus 16. We take both of these numbers, divide by 2. That 2 is coming from here. So this will be equal to bracket x plus 5 over 2 bracket x minus 16 divided by 2 is 8. And so this will be equal to, in this case, technically there is a 2 out front. 2 bracket 2x plus 5. That 2 now disappears in this next line, actually. Bracket x minus 8. The 2 comes in and multiplies these ones. And here's our final factored expression. There's one more step that's going to be involved in this, and it's grade 9, quick review of grade 9 to solve these equations here. They're one-step and two-step equations. To solve this, bring over x to the other side by doing the opposite operation. The opposite operation of plus is minus. X is equal to minus 6. I'm showing this step just because it's a quick review, but in practice I would actually go from here to here. X is equal to 15. 3x is equal to minus 15. Divide by 3, divide by 3. X is equal to minus 5. 3x is equal to 4. Divide by 3, divide by 3. X is equal to 4 over 3. Okay, so in this next lesson we're going to be looking at solving quadratic equations, and everything we've just done on the previous slides we're going to be combining into solving quadratic expressions and equations. And here our ultimate goal of this lesson is to solve quadratic equations that have real roots using a variety of methods. This coming straight from the curriculum documents. A sample problem is solve x squared plus 10x plus 16 is equal to 0 by factoring and verify algebraically. I know I've met my learning goals if I can determine the x values by factoring that satisfy the following equations. So this could be your self-assessment at the end of this, and each one of these questions varies in its level of difficulty. Just a quick recap, the big picture of these units is to look at going between different forms, but specifically we're going to be looking at this one here today, which is the standard form, and we're going to be setting it equal to a value. And it's also going to be related to this here, because eventually what we're going to do is we're going to convert from standard form to factored form and then use that to solve. Here we've got some key terms. The quadratic equations. An equation is something, an expression with an equal sign in it. So there's equals, and we're going to look at when it's equal to a number and we can solve it, whether it's 0 or some other number which is positive or negative. And ultimately this is going to turn into finding the x-intercept, zeros, or roots, and this is where the parabola crosses the x-axis. In this question, we're asked to solve by factoring. So we factor this expression. Two numbers which multiply to minus 15 and add to 2 are 3 and 5. So this is x plus 5 times x minus 3 is equal to 0. And what this boils down to is finding out when each one of these expressions are equal to 0. X plus 5 is equal to 0 when x is equal to minus 5. X minus 3 is equal to 0 when x is equal to 3. And what we're doing is we're solving these equations separately. And the other thing that this is asking us to do is to verify that this is true. And so I'm going to show that that is true. So if we were to take this factored form and substitute these values back in, we should get 0. So 5, and we're going to say x is equal to minus 5. Minus 5 plus 5, and minus 5 minus 3 is equal to 0. Minus 5 minus 3 is minus 8 is equal to 0. So that works out. We wanted to make it 0. Now if x is equal to 3, this is a second check. 3 plus 5, we're substituting in the x is 3. 3 minus 3. This is going to be equal to 8 times 0. 8 times 0 is just going to be 0. And you could also take these numbers, the minus 5 or the 3, and put them into this equation, because these are equivalent, and you should get 0. Sometimes when you struggle to find a factor, you can also use a guess and check method by throwing numbers here in to try and find what equals 0. It's a trick that my grade 12, or technically grade 13 math teacher would have taught us. We're going to solve by factoring. And this is a little bit different than the last one because you got these numbers on the right side. But what we're going to do is we're going to bring them back to the left side and make this one equation where it's set equal to 0. And what this is saying is, when is this expression equal to 80? And ultimately we have two answers, or we expect to have two answers, because this thing opens up and we're going to have, wherever it hits the x-axis would be the answers. So that's for the visual learners. That takes us a little bit away from the algebra. 3x squared plus 9x. When we bring the 80 over, it turns into minus 84 is equal to 0. And if you're paying attention, or this looks familiar, that's because it's the expression from the very first set of slides with the review. We factor the 3. This turns into x squared plus 3x minus 28. We factor this trinomial, 3 bracket x. Two numbers which multiply to minus 28 and add to 3 are going to be plus 7 and minus 4 is equal to 0. And what we do to solve this are, when are these two expressions equal to 0? Well, x plus 7 is equal to 0 when x is equal to minus 7. And if we substitute minus 7 in here, we could verify that it's 0, just like we did in the previous example. X minus 4 is equal to 0 when x is equal to 4. So these are our answers. And visually, what this shows us, if we were to graph this, is that we've got two answers. We know that this parabola opens up because this number out front is positive. There's going to be a minus 7 over here. There's going to be a 4 here. And our parabola looks something like this. And that's what we can see at this point. We could also go one step further and say that this y-intercept here is minus 84. Doesn't look like it based on my diagram, but we know that from this this expression right here. That is the y-intercept. Let's take a look at this next one. Bring over the 35. That turns into 2x squared minus 11x. 5 plus 35 when it comes over to the other side turns into plus 40. Again, I've used the exact same equation from the review slides. We factor this, There are no two numbers there's no common factor here, so we go 2 times 40 is 80. We're looking for two numbers that multiply to 80, technically minus 80, and add to 11, and those numbers were 5 and minus 16. So this will turn into equal to, and we divide these by 2, divide by 2. Our numbers will end up turning into, the 2 comes up next to the x, plus 5. That's this answer here. And this other one will end up being x minus, well, 16 divided by 2 is just 8. And so this is transformed into this thing here, but technically, one thing I've done which is kind of bad, which I should correct, is that we must make sure that this is still equal to 0, that we're not doing expressions where we're doing line by line. This is an equation. What we need to do now is find out when these are equal to 0. 2x plus 5 is equal to 0 when, and our initial reaction is, when we see these questions, it's going to be minus 5. It's not the case here. This is a two-step equation. 2x is equal to minus 5, and we divide by 2, divide by 2. X is equal to negative 2 over 5, negative 5 over 2, or x is equal to minus 2.5. On the other side here, we've got x is equal to x minus 8 is equal to 0. That's when x is equal to 8. You could verify that if you put in 5 here, you're not going to get 0. And again, you could substitute these values into this expression, and they should give you minus 35 for both of them. Again, it comes down to a transformation where we find roots. This is our final question. The height of a rocket is modeled by the equation h equals minus 2t squared plus 33t minus 25, where h is the height of the rocket in meters, and t is the time in seconds. When will the rocket be at a height of 20 meters? And visually what's happening is we've got this parabola that goes up like this and down, and this height is 20, and what we need to do is find these t values. What are these t values? And we can do that by substituting h equals 20 into this equation, and eventually it will transform into finding roots. Minus 2t squared plus 33t minus 25 is equal to 20, coming from our substitution. Minus 2t squared plus 33t minus 45 is equal to 0. We're going to get rid of this negative by multiplying both sides by negative, and we can do that because there's a 0 over here. 2t squared minus 33t plus 45 is equal to 0. And right now it would be nice if we could factor out the 2, but we can't, so we need two numbers which multiply to 90 and add to minus 33. Those numbers are 3 and 30, both negative. Divide by 2, coming from the a value. So this will factor into bracket 2x minus 3, coming from this one, and x minus 15. I guess it should be t, not x. So what this tells us is 2t minus 3 is equal to 0. T will be 2t is equal to 3, divide by 2, divide by 2. One of our answers is 1.5 seconds. T minus 15 is equal to 0. T is equal to 15 seconds. So our answer will be the rocket is at a height of 20 when time is equal to 1.5 and 15. I'm a bit guilty today because usually I give you guys some more things to work with and examples to try while we go through the lesson, but there's so much to go through, and as I always say, math is not a spectator sport. You will only get better by practicing. So here's your homework questions for this for this lesson. Thanks for watching.